Okay, good afternoon, for me at least. I will show you quite fast how you could draw a derivative function with help of the calculator without knowing which equation that describes the derivative function. It is possible to do it. The calculator do it numerical, so without finding the derivative function. And I will show you with an example so we can realize that it has to be true because we know the answer already. So let me draw for you y equals x squared. It's a well-known function and you draw it like this. So x value, y value, something like this, starting with negative infinity for the x values, infinity values for the y values, going down and going up again. So this happy mouth that you see here. Now, if you differentiate it, you get y equals 2x, that is y prime. And if you want to draw that on in the same diagram, so then we have two things on the y-axis, y prime as well. And it's a straight line, goes through 0 and 1, 2. So, let's see, something like this. It's a straight line and it goes something like this. Now, let me show you that a calculator can actually draw this straight line. So, I will use TE84 plus here. And I will go into y equals. That's where you draw the function. However, in this case, I would like to have the derivative function to a function. And it's possible to get it if you go into maths. Maths. And then you go 8 steps down until you reach n-deriv. And this program for you is letting you calculate a specific value for a specific x value. And in this case, it will calculate a lots of values for different x values. And that is the gradient for this curve in every single point. So it calculates the gradient for this x value, see that it becomes very negative, so it makes a point here. Calculate it for the next x value, see that it's quite negative, so it makes a point here. Here, the gradient is 0, therefore it's in the origin. Then we get positive gradients, so we have positive values. So this program calculates the gradient for lots of x values. And with help of them, it could draw the line. So d dx, the Leibniz notation for derivative. And we want to differentiate with respect of x. That's how we do it. And then we have the function inside the brackets. That's normally dy. But y is equals to x2. So I'm writing x to the power of 2. And then I go down to x equals. And normally when you use this n-deriv program, you choose a value for x, like 1. Calculate the gradient for the graph when x is equals to 1. But now I'm just writing x. So I wanted to calculate the gradient for lots of different values of x and then connect all the values with a line. That's how you do it. Now let's press graph. And then you can see the straight line here. And that is, the calculator don't know it, but that's y equals to 2x. So it just gives you the value for the gradient for different x values and then connect them with a line. It's called numerical differentiation. I think this may be useful for you, at least if it's an exercise on paper 2, which asks you to draw the derivative function by hand or with calculator. So you can do it on the calculator and then just sketch it on your paper. Okay, thank you and goodbye.